How do you kill a superbug? With a super exterminator? No, with viruses or phage therapy. But first, what's a superbug? Is it just a bug superhero? No, a superbug is an antibiotic-resistant strain of bacteria. Antibiotics cannot kill superbugs, and they are potentially fatal if present in the human body. Just this year, over 2 million people were infected by superbugs, and over 23,000 were killed by them. So how do superbugs get formed? Hint, by developing resistance to antibiotics. A bacterial infection occurs when a harmful bacteria enters a body and then multiplies. So in 1929, when bloodletting, bleeding out a patient's infected area, was the primary way to deal with infections, Alexander Fleming's discovery of penicillin was direly needed. But there are drawbacks. Antibiotics' main way of combating harmful bacteria is by killing all nearby bacteria, which means it can't tell the difference between good and bad bacteria. Even though bacteria can evolve to become antibiotic resistant, antibiotics cannot evolve. Here's a demo of how antibiotic resistant bacterial infections can form. This represents mutated bacteria. And this represents antibiotics. Here's a petri dish full of non-resistant and antibiotic-resistant bacteria. With the first wave of antibiotics, the non-resistant bacteria are killed, and the same thing happens with the second wave. By the third wave, it's clear that the antibiotic-resistant bacteria are not going to be killed or damaged by the antibiotics, and they then multiply to create a bacterial infection. This is where phage therapy comes in. Here in my hand live millions of individual bacteriophages, each tailored to kill and infect one specific type of bacteria. Unlike antibiotics, bacteriophages are literally everywhere. There are more phages on Earth than all other organisms combined, and each phage is tailored to infect and kill one specific type of bacteria. Since phages are just viruses, they naturally evolved to combat a particularly resistant type of bacteria. So we get it, bacteriophages are really important.
Duh.
And they're really good at killing bacteria cells.
Didn't we already know that?
But how do they kill bacteria cells? How do they work? For a closer look, let's go back and see millions of individual bacteriophages and zoom in. Here's the basic bacteriophage structure, complete with the head, or the capsid, the collar, and the tail. If we zoom into the capsid, that's basically where all the genetic information, or the RNA, is stored. Similarly, if we zoom into the tail, we see that the tail is where the magic happens. Since the tail is the interaction with the bacteria, it can penetrate the cell and cause the virus to spread. Two types of bacteriophages. Lytic bacteriophages kill immediately. Histogenic phages take over the genome and kill gradually. At the end, however, both phages will always kill the bacteria and prevent future bacterial infections.